Hey everybody, this is Larry. This is day 7 of the LeetCode Day Challenge. Hit the like button to subscribe and join me on Discord. But also look at fireworks in my background. Yay! Alright, let's do today's one. Hey, yeah, hope you liked the intro. It is day 7 of the LeetCode Day Challenge. I was on the West Side Highway here in New York City, and I saw fireworks, of course, because they always have fireworks for me. So I figured I'd show the rest of you what it's like on one of my runs. That's pretty much it. There was nothing like special or anything. I don't know why they're doing it, and it's also on the New Jersey side, to be honest. So I don't know if there's like a New Jersey thing going on, but anyway, and I was just doing my quick 5 easy miles, which might as well be a rest day at this point. But yeah, let's go. Let's do it. Let's get through this because I need to use the restroom. Not gonna lie. I guess I could have paused this. If I have to pause it, I have to pause it. But anyway, yeah, let's take a look. Today's problem is 1367, linked list in binary tree. So given a binary tree root and a linked list head as the first node, we turn true if all the elements in the linked list starting from the head correspond to some downward path connected in the binary tree, otherwise we return false. In the context, downward path means a path that starts at some node and goes downwards. Okay. The tricky thing is that you don't always have to start at root, it seems like, because look at example 1, you could start, yeah. How would I do this? I mean, I think the tricky thing that I notice is that the nodes don't have to be unique, right? So it could be a little bit annoying and tricky if you're not careful. And what I mean by that is that my first instinct was just to do a depth first search and then just kind of do like a moving pointer thing, right? But it doesn't really work. And if all the values were unique, then it would work. But because they're not, it could be a little bit tricky. And why I say that is because, imagine for now you have a tree that is a linked list, right? You have a tree that's a linked list. So then your tree looks like this, right? And then 5 or something. And then your linked list, your actual pattern or whatever, looks like this. Whatever, right? Then now, well, maybe not quite this, but whatever. Something similar to this idea. Then now you're gonna do. It's gonna be n squared in the worst case because you can start. Like if you do a backtracking thing, you can start here, 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 and here, and here, and so forth. Like I mean, assuming that you kind of you could extend this to a lot more fours, for example. And in that case, it's going to be n squared or something similar in the worst case, and that's just probably too slow, right? 2500 is not that bad, actually. 100 for this is actually not that bad, so maybe we're okay. Yeah, let's try then. I mean, I guess when I say n squared, I guess it's n times l, where l is the link with the linked list. Let's give it a spin. I guess that's why this is a medium, because I think... Yeah, I mean, I guess this is why this is a medium, in that you can just brute force it. Otherwise, I mean, you definitely can do this. Because the way that I'm saying it right now, right, as you kind of see how I structure it kind of a little bit, basically we're trying to see, okay, does this match the first thingy? And then does this match this thing? And then does this match this thing? Right? I mean, of course, given this is a tree, the actual branches, it gets a little bit more complicated, but not by that much. I think there is a LeetCode Horde that is the same problem, more or less. Maybe not with a linked list as one of them, but like a tree and you have a pattern or something like this. I think that's a LeetCode Horde. You probably have seen it, or you could find it. I don't know what it's called, because they use some like really funky naming, so I don't know what it's called. But I'm pretty sure I've seen it before. And in that case, you can probably do some, you can, as you can kind of see this and this. This is like a string matching problem, right? Like a needle in a haystack problem, right? So so definitely look that up, right? And pattern searching or whatever, right? Something like this. And and there definitely is a linear time solution. Linear would be O of 2500 plus 100, so n plus L instead of n times L. But it seems like these constraints, n times L is okay, so we'll just do that. Remember, this is a medium, and we'll just do whatever. I mean, and you can upsolve this afterwards, but you know, your first thing should be focus on solving it first. Don't upsolve before you solve, right? Or you can, I guess. It's up to you. If you're very confident, just know what you're working on, know what you want to get better on, and then do it, right? It's fine to do both if you want to, right? And you know, with this idea, maybe you can even implement that without that much more of a hint. But yeah, for me, for now, I am going to do it the brute force way, and even that is maybe not straightforward. So let's give it a spin, right? So yeah, so we just have a it's so node no node is such a okay, fine. List node and tree node, right? So it's a little bit more self-explanatory, right? So now we're matching. Is there a match in this subtree starting at this list node, right? Okay. So then if list node is none, now I guess we'll just return false. I think. I mean, technically, I guess it's true because it just means that we did all the list nodes. It depends how you want to define it more precisely, but it's, yeah. And then otherwise, if list node dot value is equal to tree node dot value, right? Then we want to either go left or go right, right? So then now we return is match. Well, it doesn't have to be, right? So yeah, so is good match maybe? I don't know, match good is equal to false, right? So then maybe good match. We want to OR it with is match of list node dot next and tree node dot left, right? Or this, right? Why is there an extra space? Okay, yeah. Something like this. But we actually should do an early termination just to make it a little bit, yeah. So maybe we do something like, you know, if this is true, then we return true. Maybe that's a little bit cleaner. It's so that we don't, this is so that we don't, oh wait, yeah. This is so that we don't, so that we early termination, so we don't do this work if this work is good, right? That's basically it, really. If tree node is none, then we return false. I forget the case because this assumes that list node has a value that we are not matching with the tree node, and so this is if it's equal, but whether it's equal or not, we can also skip, right? So this is almost like a this is match one character or one node, and then otherwise we can just well, we don't skip by looking at the thing. But actually, I guess you have to do it one node anyway. So maybe if head dot value is equal to tree node dot value, then we start a new thing from here, right? Then we can maybe do something the same thing here. So those are the two things, right? Either we continue or we start a new one, and this would be head dot. Oh no, not head. No, this is head. Head dot next. Head dot next, right? And otherwise, yeah. So you break it down to two cases, which is that we continue the current node linked list matching, or we start a new list. So I start a new thing here, right? But there's one more case. So rather start a new thing here, or we just also go left or go right, right? With the yeah. How do I write this? Because basically now you want to skip. You also want to skip this node, right? So yeah. So maybe we can just like return is match head. I don't know if this is the cleanest stuff. Something like this. And maybe we don't even need to do this then, right? Because if we skip the node. Yeah, I don't think we need this. We just skip this node. Is that true? I'm trying to go through the cases in my head, honestly. Can I skip this node? Start a new thing here. Okay, so this is the same. I think we probably need it, but I don't know. Maybe this is a little bit yucky, actually. I don't know. But yeah, and then we just return is match head root. And I think we're good. Let's kind of give it a spin. Looks okay, but honestly, I'm not super confident. This case is fine. This case is okay. What's another case, right? I mean, I guess that case is fine. I mean, I think there is like a timeout case that we would test, but I'm a little bit lazy in constructing it. Like it's something like like I actually I don't know. This tree thing is a little bit awkward, but maybe I'll just have a lot of force. Right? Maybe that's fine. I don't. Yeah. Okay. I don't know. I'm a little bit lazy, so I'm just gonna YOLO submit. Hopefully this is good. Apparently I did this, wow, 4 years ago on Leap Day too. Maybe it times out, I don't know. Because we do check a lot of things. Yeah, this is the case that I was kind of worried about. But I'm actually surprised that this doesn't. Huh. I mean, we might need to do the other thing anyway, so maybe I was wrong with maybe I was wrong with the way that I did it. Let me think a second. So basically, each no. Let me try to end. Give me a second. Sorry, my head is not in the game for whatever reason. I'm trying to think about the worst case, right? Shouldn't be that bad of a worst case. What if this is, we don't, but is this even fast enough? So this is still too slow. I thought it would be fast enough, honestly. Like just these things. What if I took this out? Because, so the reason why I thought this would be fast enough, but maybe the branching is a little bit awkward, is that for each node, maybe I'm wrong because it's a binary tree. Yeah, I mean, I thought for each node we can only start a thing. I mean, sure, it can branch out, but all right, let's see, right? But that's still n square, right? n times L, because every node can start one list. I mean, I guess if you branch, then it's two lists. And then, yeah, maybe it branches out too much. Okay. Maybe I'm wrong on this one. Then my apologies. I thought that maybe I mean, look, I'm recording these live, and sometimes Larry's gonna be wrong, and that's fine. I thought maybe that's kind of a hard medium. I think some of it, honestly, I was trying to figure out. I just assumed that because this is a medium, that I can do something like this. Hey everybody. Yeah, so I'm interrupting my video for a second, and you know that I usually do these live, and I still have done these live, but so I actually, a little bit of a spoiler alert, in the next section I solved the more difficult way, right? I know that earlier in the video I talked about the n plus L way, the rolling hash way. So I end up solving it that way, but then after that I come back to solving it the medium way, if you will, because the n plus L, the rolling hash way, is probably like a hard problem solution where you definitely should familiarize yourself with the medium solution first, honestly, which is why I did it this way. But I implement this clearly a little bit incorrectly, right? So I'll put it in the chapter, like in the YouTube chapter thing, so you could go to where that section is, and then come back to the rolling hash where this section is afterwards. I'll also put that in the chapter things, right? So yeah, my apologies that you have to jump around. I mean, and you could also watch it like in the way that I did it if that you prefer. But I just want to give you the option because I kind of did this one in a very awkward way because I did it with multiple ways, right? And I kind of didn't, like, usually if I want to do it in multiple ways, I do it the simple way first and then build myself up to the harder way. But in the live portion of this, I kind of did this in reverse. So just want to give you a heads up. Anyway, let's get back to the Larry from the past. Let's go. But also, honestly, I could be wrong, right? So so yeah, I mean, we definitely know the quote unquote the better way of doing it, but I thought that this would be good enough. Okay, I mean, it is what it is. Yeah, okay. Let's start over. My apologies. But it happens. I'm not 100% all the time, I suppose. Usually not this long though. But yeah, let's do the rolling hash, right? So let's go for it, right? So we kind of talked about this. What's it called? Needle in a haystack. Rolling hash. Or yeah, problem. There are many ways to do this, right? There's KMP. There's like boiler more. Did I make that up? No, and there are a couple of ones, right? But the one that I always go back to is what I call rolling hash, but also Robin Cobb. That's right. I was backing up on this name. But the idea behind Robin Cobb is because I know that people talk about remembering patterns and remembering data structures and remembering all these things, but for me, or like not even remembering, just about memorizing these quote patterns and code and all these things, right? For me, the reason why I love rolling hashes is because it's very easy to remember, and not even easy to remember, but just like I never remember code for the most part, but I remember concepts, right? And the reason there are basically two. I mean, for more details, for deeper dive and deeper understanding, definitely, search on YouTube and find them. This is a topic that I'm sure people have made beautiful videos on. That's fine, and definitely check that out, right? But for me, for Larry, I already have a reasonable understanding of it. I'm not just saying that humble brag, but maybe I am. No, but I'm not just saying it humble brag, but here's what my how I remember it, right? So how I remember it is not necessarily the way that should be taught, just to be clear. So definitely make sure you have a deep understanding first, and just like at least learn the basics. Maybe not a deep understanding, but learn the basics of what is Robin Cobb, right? But the reason why I remember it is that because there are two components that I remember. or not even two. I really only just remember one thing, and that one thing allows me to kind of branch out. So, and I'll talk about how I remember it. How I remember is that it's very simple, right? It's just that given a string or a number or pattern or whatever, we hash this to we hash this, or we don't even hash it. Or I mean, I know that you do hash it later, but how I think about it is that this is or convert this thing to a base B number, right? And what is B? B can be anything as long, B can be anything as long as it's, for the most part. I mean, you don't even, it actually technically doesn't have to be even that, but it makes collusions a little bit trickier. As long as it's greater than the number of unique things you have, right? So for example, B can be maybe 26 or 27 when it comes to just lowercase alphabets. 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 B could be I don't know. I mean, like B could be 10 if you have to like a 1 to 10 number, or like 0 to 9 digits, right? And that's just a regular number because you have a base 10 number, and most of our stuff is in base 10. But you get the idea. And for this particular problem, you see that the node value goes from 1 to 100. So maybe you choose like, and it doesn't even it doesn't really matter what you choose as long as it's bigger than that. So you could choose 120. I like to choose some, I don't know, it doesn't matter, 110 say, right? And then so then now you have this base B number, and you have so you have this base B number, and you're trying to match this base B number with you're trying to match this base B number with so this is the pattern, right? So let me say again. Now you have a base B number as a pattern. We do the same thing to the what's it called? Well, I guess so I guess this is the needle, right? To the haystack, right? We do the same thing to the haystack for length whatever. In this case is a particular length, so for some length L, right? And the way we do it is by shift and add, right? And this is kind of like it makes sense in the way that if you look at everything as a base B number, right? So then now, let's say the haystack is just a bunch of numbers, right? I don't know, I'm just banging on the keyboard, so it looks really weird, but whatever. But like the random number, right? So then now, if let's say L is equal to 4, right? Then now this is the first thing that we match, and we try to create a base B number to see if this matches our haystack or our needle, right? And then next it's going to be just this, right? And with this idea is that almost like a sliding window, right? Well, actually it is a sliding window in a way, is that now you have you try to get to see the value of this window, and then you shift the window to here, and then what happens? Well, what happens is that now you have to subtract out the left side and add just like a sliding window, right? And then from that, because you know that this is some number base B, this is some number base B, it just becomes very straightforward to do the math, right? I mean, I say shift and add, but and that's how you do it, right? But you can actually, like, like if you just kind of look at this more innately, like you can kind of prove it to yourself, right? So from that's all I really need to kind of implement everything, right? So these are, I mean, like I said, there are more nuances and things, and of course there's some because this number would be too big for big enough L's. You choose a prime number to hash it against or mod it against. And there's some stuff that you can do for false positives and stuff like that, but ignoring all of that, that's just for now anyway. Yeah, ignoring all that, this is the core idea of it, right? Okay, so and that's usually what I need to do. Okay, so then now, now given all this stuff, let's put it here. Man. Right. So then now, let me create more room here for me to write code. Yeah, let's construct the pattern, right? The pattern based thing, right? So then here I always have base is equal to in this case whatever, like I said 110, and then we have a big mod. I usually just take a very big prime, like I take a random number like 22 digit. I wrote 23 digit prime. I Google for it, and yeah. And yeah, I just pick a random, and I guess it's not on screen, but I just Googled a random prime generator or something, and then here, right? So I don't know what that. I mean, it should, and it technically speaking, it doesn't even have to be a prime. It's just a big number. But of course, prime. If it's a prime number, then well, every number smaller than it is relatively prime to it. So then you, in theory, has fewer collisions. But if you have a big enough number, it probably doesn't have that many collisions anyway, unless you choose a number with a lot of factors for whatever reason, right? So then yeah, so then now we construct the pattern. Yeah, so then now we. Yeah, now we go, right? So so current is equal to head. Yeah, right? So while current is not none, we have current is equal to current.next, and this is just, iterating the linked list, right? So, oh yeah, so then my pattern is equal to 0. We shift time space, we add, what is it, current.value, right? And that's it. And now pattern has the thing we want to match, right? And then next is doing this way. So here, maybe this is a tricky part because we initially we were talking about haystack and it being a string and stuff. But here, you can just think about going on each level. Now you have a new now you have a new thing, right? Also, I'm missing something. That's why. That's sorry. I had a pause because I was missing something. But yeah, L is equal to 0. Here, we would just want, just have the length of L, right? But yeah, yeah. Now pattern has the thing we want to match, and L is the length of the linked list, right? And then next is yeah. The idea here is just that for every digit, I think the tricky thing is that we're dealing with a tree instead of a string, right? And the idea here is just that every time you branch out, it's just basically the two possibilities, right? You either, when you think about the sliding window, you either slide in to the left or the right, and you just check for both, really. Yeah, and then that should. And basically the idea here is that at every node, you have the pattern or the hash for the last L length of the tree up to that point, basically from the thing and the thing, right? And that will allow you to, well, see if it matches the pattern. So let's do it that way. So yeah, so then here we could say traverse, right? So we traverse, we have a tree node. If node is none, we return. What we also want to do is actually maybe current hash or something like this. Yeah, current hash or current, I forget what the things are called, to be honest. Yeah, and then maybe a depth. The reason why I have depth is so that we can match, make sure that we have L, and also doing some shift fee things. Yeah. Right. Okay. So then, oh, I forgot to mod here, didn't I? Oops. But yeah, and then now, yeah, we can just return traverse root 0 0, right? Something like this. If it's equal to none, we return false, right? So yeah, so now we have this thing, and I wasn't very specific about it. yet we just subtract the left side. Right? So what's the left side? Well, if we multiply this thing by b every time because we shift it to, it's like adding a new digit when we add a new digit. So the adding part should be pretty straightforward. You shift and then you add, right? But then the subtract is this number, but that number has been shifted L times, which means that the base have been multiplied L times. So you have to factor that in, right? So basically, maybe sometimes I'm off by one on this, but basically maybe you have I forget how to name things. That's why I'm like, yeah. But your base shifted maybe is equal to base, and we want to shift this L times, right? So yeah. I think it's just pow base times L, and with the minus the mod, right? It may be off by one on this one, but I think this is right. This is so that, for example, in this case, we would do it by, we would subtract out 51 times the base shifted, right? Yeah. Okay. So then now, here we have the current hash, which is already shifted, I think. I mean, you get to define it, of course. But doesn't contain the current node, right? That's why we have it like this. So then now we want something like current hash. We want to shift. We want to add, right? So then if current hash is equal to pattern, then we return true, right? Otherwise, if it's not, well, we also have to mod it. And also maybe check with depth, I suppose. I mean, there are no zeros, so it should be okay, I think. Maybe not, I don't know. Sometimes you probably should, just to be safe. But otherwise, then now, if it's not equal to pattern, then you wanna, then the result is gonna be some combination of traverse node.left, yeah, and then current hash, we want to shift. Oh no, I guess we do the shifting here, right? So that's fine. That plus one, so we return this, or we just do the same thing but going to the right? I didn't. This is a little bit messy because I'm explaining it kind of in a weird order, or because we didn't take care of depth or L. But yeah, but here we should have had it, right? So this is shift and add, but we also want to get rid of the base shifted. So then here, I'm being sloppy, I suppose. Yeah, okay, fine. But yeah, but basically if depth is greater than equal to L, then we want, and something like current hash, we want to subtract base shifted and then times like the digit that was like a few like L ago, right? So if given the sliding window idea, you have to know what to kind of subtract from the sliding window. So I think I messed up here. I mean, not hard to fix, but I just okay. Like I feel like I'm a little dumb, but yeah, okay. So then here I guess we don't need read depth. We just need I mean, it'll be encoded in here, but it's just like previous nodes or something like this, right? So then now let's actually clean this one. Alright, let's just yeah, if length of previous is greater than L, then is this minus previous negative L or something like this. Maybe negative L plus 1 or something. But it's just like length of previous. So the last one is going to be 1. So we want, it should be this, right? I think this is right, but like I said, could be off by 1. But yeah, now we have to be a little bit cleaner, right? So then we have previous dot append, no dot value, So I guess if we return true, I don't know. It should be okay though. So yeah, if this is true, then we return true. This is true, we return true, and then we just return anyway. So return false, otherwise we, well, this is popped, right? It's a little bit yucky actually, but yeah, okay. Let's give it a spin just to see if it works. I don't know. Ooh. Okay, I think okay, yeah, let's put this one in here. Yeah. See, now is much faster. To be honest, I'm not super confident because I feel like I'm way wonky on some of the possible off by ones. I mean, the idea is gonna be right. I mean, I'm confident about the idea, honestly, but it's just a lot of possible off by ones. So I'm like, and maybe edge cases. But that said, I am lazy today, so I am gonna submit it for y'all. And okay, yeah, looks good. 16-21 day streak. Yeah, looks pretty okay. Yeah, yeah, I didn't think that, I thought this would work, honestly. What did I do last time? Yeah, last time I don't know about this started thing, but last time I just did it, I thought this would work, and I guess last time I actually did it correctly. Why is this, maybe this, maybe I was just missing this idea of having a node that started. Maybe I branched out a little bit too weirdly. How did I do it here? Start a new. Maybe I mean, I think I probably duplicate some state here is probably why, or like the skipping the node thing. Well, skipping the node is starting a new thing, but I don't know. But I even tried removing this and it didn't work. Head. Otherwise, we start and skip this node. Why is this too slow? Or how is this different from like this other funky solution that I had from 4 years ago? It's either that or like I'm curious whether this works still. Like I don't know, maybe they just add more input to something. I'm just like fooling myself real quick. No, this is fast enough, so maybe I'm just like really bad at it today. And I did the sliding window thing. And this is too slow. Okay, so I don't think we need this, honestly, but it's still too slow. We skip this node. We go to, if this is eco, we go to this node. Yeah, if it's equal, then we check the left, we check the right on the next node, right? Otherwise, we skip this node and try again. Why is this so much worse than the other one? Because each node can only I'm just sorry, friends. I'm just trying to figure out like what is the difference here. Apparently the Larry from 4 years ago wins this time, almost 5 years ago now. But so we started it. Oh, I see. It's because I do the skip the node way too many times, because if this is not the head node, then if this is wrong, you should not skip. You should just return false, because that ends that branch. So I was starting from each node way too often. Okay, I see. So then here it should be, yeah. If this is head, then yeah. Otherwise, we skip this node as a new head. So okay, so I think if I rewrote this another way, this would be good as well. Which is that okay? So I tried being too clever by doing it in one function. And I guess that's a very common thing. But yeah, then now we have here is match right? Okay, this looks good. Basically, we always continue. Otherwise, it's false, right? And then now we have a second depth first search, right? Of start from, and then we have a tree node thing, right? So then now with tree node is none, we return false, I suppose. Otherwise, then we say yeah. So then we otherwise tree node is not none. So then if is match head tree node, return true. Otherwise we return is match head dot nope. If it's match, it's true. Otherwise we otherwise we return I almost did it again. Start from tree node dot left or start from tree node or dot right. I think the way that I think the idea was right, but the way that I wrote it, I was starting from each node way too often. I think that's the thing. So okay. Yeah, okay. Huh. I was being very sloppy because that's the problem was that every time, like even in the middle of a linked list matching, if it doesn't match, I skip the current node. But that means that I start from each node way more often than I did. A very small, even though the analysis I was kind of right, but the implementation I messed that up. The funny thing is that if you added a cache thing, it would have worked. Just because then now it doesn't do the same node multiple times, which you might not have expected it, but it's still a little bit awkward to kind of have that. Like I think if we had just added a cache, I think that actually ends up working as a result of duplicating. But this is one of those like magical things where if you don't know what you're doing, you'll be like, okay, just add a cache. But the reason is because I was calling this too many times, where there is a unique way to call this such that yeah, it is not. So yeah, okay. Yeah, I think this is the solution that I think this is the reference solution, but yeah, or that this is the reference solution that I would like to people to use. I don't even care. I mean, I think I went over all the possible solutions on this one, but yeah, that's all I have for this one. Let me know what you think. Thanks for watching. We really we really did a deep dive on this problem, so yeah, let me know what you think. Thanks for watching. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.